today we want to look at what algebra tiles are and how they can help us in algebra. So algebra tiles are these manipulatives or little hand toys that we can play with that help us kind of see why we use variables and how those variables would interact and why we can combine sometimes and why other times we can't. We're going to start with the smallest piece in the set of algebra tiles. It generally looks like a very tiny little square. Usually has a length of 1 and a width of 1. So if we were to find the area for that, area is length times width, which for us would be 1 times 1, which gives an area of 1. So this piece would be considered a 1 piece. Usually when you buy algebra tiles, you would buy a set that has, like, say, a red and a yellow in it, or maybe a yellow and a blue. Generally they have two colors so that they can designate one is positive and one is negative. For our purposes, since we're drawing it out, we're going to have an unshaded one equal to a 1, and then we're going to have a shaded one that would be equal to negative 1. So if I take a positive one and a negative one, what happens? Well, those two things cancel out. So if I have one that's unshaded and one that's shaded, they cancel each other out. This would be known as a zero pair, because when they're added together, they cancel each other out and form 0. So 1 plus negative 1 would be equal to 0, which is why this would be called a zero pair. Now, if I wanted to show you the number 5, I would put 5 of them out there. So 1, 2, 3, 4, 5. And of course, when we're drawing them, they're going to look a little weird. But if you actually purchase one of the sets, they are generally, all the same size and perfect. This would represent 5. If I shaded them all in, it would represent negative 5. Do you see how that works? Great. Next, the next piece after a 1 has a length that is not 1, but a width that is 1. The length we don't know, so we're going to call it an x. Now, just like we did with the 1 piece, we found the area. So length times width. So our length is x and our width is 1, which gives us an area of x. So this one we're going to call an x piece. So if I drew an x piece over here, I could draw a negative x piece, and I can make it negative just by shading it. So this first one is x. The second one is negative x. If I wanted to represent 3x, then I would draw 3 of those. 1, 2, 3. And I would add them together. 1x plus 1x plus 1x is 3x. If I have a positive x and a negative x, just like having a positive 1 and a negative 1, I can also create a zero pair. And that's going to be helpful for us as we're trying to simplify some expressions. So this is an example of a zero pair, just like this was an example of a zero pair. These are things that cancel out, one positive and one negative. Other pieces that are used for algebra tiles. Sometimes there's something of a different length. Now when I say different, it doesn't necessarily mean more, it just means it's different from what we've had before. So if I was using my area concept again, length times width, I have a length of y and a width still of 1. So I have a piece that is y. So I have an x piece and a y piece. And generally in algebra tiles, if they bother to give you both pieces, the y is typically longer than the x. Once again, that doesn't mean that the y number is always bigger than the x. It just means it's different. So here, if I was to have a y piece, and then I put another y piece with it, I would have 1y plus 1y, which would equal 2y. If I made one of them positive and one of them negative, remember we made it negative by shading it, then they would cancel out, creating another zero pair. There are some off-the-wall kind of shapes. We could have an x length and a y width. And that would create something that looks like this. So if we're following our area concept, x times y would give us an xy piece. So this type would be considered an xy. Once again, we can have the positive kind, or we could have the negative kind. And based on what we've been doing here so far, the one that's shaded in is the positive one. I'm sorry, the one that's shaded in is the negative one. The one that's unshaded is the positive one. And if I group those together, they could form a zero pair. I would have xy plus negative xy, and they would cancel out, giving me 0, which is what makes them a zero pair. So you're probably asking, what if it has a 0 on either the length or the width? Well, if it has a 0, it's not going to show up at all. So if we had a 0 width or a 0 length, we wouldn't see it. Next question you might ask is, what if it has an x length and an x width? Well, that would be an x length, and we'll make it an x width. Let's talk about that area concept again. Length times width, so we have x times x. And we're going to be studying this, but x times x gives us x squared. This is when we go through and add our exponents. Like I said, we're going to be studying it, but these algebra tiles are going to help us. We just need to know for now that this is an x squared piece. Once again, like before, we have a shaded and an unshaded one. So this one would be a positive x squared. You can also think of that as 1x squared. And then if I drew another one, but I had it shaded in, then that would be considered a negative x squared, or a negative 1x squared. If I tried to add those two together, they would cancel each other out. So 1x squared plus negative 1x squared is equal to 0. So these two pieces together would form a 0 pair. You might also see this written as x squared minus x squared. This one being a positive x squared, this one being a negative x squared. Of course, the same thing happens if we have a y. If we have a y length and a y width. So y by y would give us a y squared. Following our area concept, we had a y times a y, which is a y squared for our area. And of course, we could draw positive ones and negative ones. Well, how is this going to help us? One of the things it's going to allow us to do is combine like terms, which we've already studied how to do. Remember when we were talking about combining, we said this had to be by addition or subtraction? And like terms meant they had the same variable with the same exponent. So those look like the numbers 3 and 5, or 4 and negative 7. Those were like terms. Things like 3x and 5x were like terms because they had the same variable with the same exponent of 1. 7x squared and 9x squared would be like terms with each other because they had the same variable with the same exponent. If I combined all 4 of these together, they would not all be like terms. These two would be like terms, and these two would be like terms, but all 4 of them together are not like terms. If I did something like this with a 3x squared and a 5y squared, I would have to say they are not like terms because even though they have the same exponent, they do not have the same variable. If I gave you an example that looked like this, 5xy squared and 3x squared y, this would also not be like terms because the x's do not have the same exponent and the y's do not have the same exponent. So they do not have the same variable with the same exponent. So let's see how algebra tiles can help us combine like terms. Say for my first problem, I have 3 plus 2x minus 7x plus 5 minus 2. And I want to know what that's equal to. Well, I could draw these pieces out using my algebra tiles. There's 1, 2, 3. 2 x's, those would look like longer pieces. So there's an x, and there's an x. Then it says I have negative 7x. So there's 1, there's 2, there's 3, there's 4, there's 5 and 6, and there's 7. I will shade them in because they're negative pieces. Something like that. So that takes care of our negative 7x plus 5. And then we have a negative 2. And we shade them in because they're negative. Now what we do is we try to combine all of the ones that have the same size, same shape. So this negative and this positive cancel each other out. Those would be considered a zero pair. Same thing's going to happen here. Positive and negative are going to cancel out. Another zero pair. Here, a positive and negative x cancel, and another positive and negative x cancel. Now let's go through and see what we have left. We have 1, 2, 3, 4, 5, 6 of the 1 pieces. Now we have 1, 2, 3, 4, 5 of the negative x pieces. So we have 6 minus 5x. Could we write the minus 5x first? Sure. It was a negative 5x because they're shaded in. And then we have 6 positive pieces. These two mean the same thing. You notice here the 5x is negative. Here the 5x is negative. Here the 6 is positive, and here the 6 is positive. So, I'll pull an example off the board. I have some large algebra tiles on my board. This is considered an x piece. This would be considered a negative x piece. These together would form a zero pair. They would cancel each other out. So say I have 3 of this red one and 1 of this yellow one. This means I have 3x. I'm sorry, just 3. We're not looking at x pieces. We're looking at 3 1 pieces. And then we have this big negative 1 piece. So 3 minus 1 would give us 2. 3 of the 1 pieces is equal to 3. 1 of the negative 1 pieces is equal to negative 1. If we combine those, here's our zero pair going away. I have 2 pieces left. Now, like I said, depending on what company made your algebra tiles, they could be a host of different colors. So on this set, I have some larger x and y pieces. We have green and red. So for this example, I'm going to say that red is positive and green is negative. So this is 2x minus 1x. These two are going to form a zero pair and go away, leaving me just a 1x. So that's just like us having 2x minus x, these canceling, and us having a 1x left.